Well, hello. Today, we are working on Lesson 5, and we're going to be solving problems by finding equivalent ratios. Seems pretty easy. We've done some equivalent ratios. We've worked with a few different ways of finding equivalent ratios, including using a tape diagram. And now we're going to work with an actual word problem. So, let's get started. Our first example is pretty long, and usually that turns us right off of doing math. But let's try to work through this one. A county superintendent of highways is interested in the numbers of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars, pickup trucks, and at the local Department of Motor Vehicles, the DMV. You all might be familiar with that. The DMV reported that in the month of August, for every 5 passenger cars registered, that's cars that have passengers, obviously, there were 7 pickup trucks registered. How many of each type of vehicle were registered in the county in the month of August? Okay, so the first thing we always do when we look at a word problem is kind of get an idea of what's going on. So make some mental pictures in your head. Let's do some information that we learned from Solve, starting of course with underlining the question. So let's go ahead and do that because we definitely want to make sure we don't get caught up with too much. Okay, how many of each type of vehicle were registered in the county in the month of August? That's the ultimate question, but we don't necessarily have to figure that out right away. Remember, we're trying to find equivalent ratios, so let's go ahead and look at A because A is going to help us work through this problem. I'm going to take it apart piece by piece like a puzzle. A says, using the information in the problem, write 4 different ratios and describe the meaning of each. Now before we go crazy and say, oh no, there's only one ratio, let's look at that one ratio we can find. Here's the number we have, but there's more than that. This is a total number of registrations, and I don't know that we can work with that just yet. So let's look at, find our ratio. Remember our keywords, oh yeah, for every, there we go, for every 5 passenger cars registered, there were 6. So let's highlight and bold that one. Actually, I like different colors. You know me. For every 5 passenger cars registered, there were 7 pickup trucks registered. A lot of extra words. I think the ones we have to pay attention to are the numbers. 5 to 7. So for every 5 passenger cars, there were 7 pickup trucks. Okay, so we can work with that. Our first ratio can be 5 to 7. Now what you don't know is when we have a ratio like that, that is called a part to part ratio. And this refers to the cars to the pickup trucks. Okay? Can you come up with another ratio with maybe moving some numbers around that's similar to that? Okay, 7 to 5 refers to the pickup trucks to the cars. We could certainly move some things around, right? Well, that is also called a part to part, ratio. Now the reason why these are called parts to parts is because we're taking the total amount, the total of cars there are, we're talking about here in this ratio, and we're putting them into 2 different pieces. So part and part. So if that's the case, they want us to come up with 4 different ratios. I wonder how many parts, if we put all these parts together, how many there would be. Can you come up with another ratio using some of the information we have down here? Well, we could say, if we did trucks to the total amount, we could say, well, let's go with the cars first. 5 cars to, altogether, behind the ratio, we would say there are 12 parts. That's the whole number. So, we could say that this is a part to whole ratio. So, what could the other and last ratio be? Could it be another part to whole ratio? Why, yes, it could. The first one talked about, the third one, I should say, talked about the cars to the total number of parts that were registered. The next one can be the trucks to the total number of vehicles that were registered. So this other one is also a part to whole ratio. Now, that will come into play in a few minutes. All right, now that we've completed A, let's go on to B. How about if we make a tape diagram that represents the quantities in the part-to-part ratios that you wrote? So the part-to-part ratios would be this one or this one. Let's do this one. Both of them, it really wouldn't matter, but we'll do the cars to trucks, and we'll draw a tape diagram and label them. We could do that, 5 to 7. Go ahead and do it on your own while I do it here. Well, I think this one wasn't too hard for us to make a tape diagram based on our 5 to 7 ratio. 5 being the passenger truck cars, and 7 being the pickup trucks. 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5, 6, 7. Okay, B is done. Now C says, how many equal size parts does a tape diagram consist of? Okay, well, if we're looking at the equal size parts, we're going to be looking at all of them together. So if we combined all of these together, and they're all the same size, we can say that there are 12 equal size parts. So 12, that's an easy number to answer. D, what total quantity does a tape diagram represent? Now that's an interesting word, represent. Well, if we needed to know all together, we're talking about all the cars together, there are 12 parts. But how many cars and trucks altogether? How many vehicles? Well, that's where we come back to our total of 192. That tells us, no, just the 192. That tells us what these parts all represent. So the total thing, the total number of vehicles we're talking about here is 192. All right, this is very nicely walking us through the problem. What value does each individual part of the tape diagram represent? So if there are 12 parts, and all together, they'll have to come out to 192. What goes inside each part? Remember, in our tape diagram, this number has to be the same. That's where our C comes from, our little c. It has to be constant. So what number would be constant if altogether it's 192? Hopefully, what we're thinking about when we're thinking about putting 192 individually in each box, we're thinking about separating the numbers. And the best way to separate the numbers is to say 192 divided by 12. Because that's what we're really doing. We're taking 192 and dividing it by these 12 boxes, or dividing it into these 12 boxes, if you'd like to put it, each unit. So, on your math paper, figure out what 192 divided by 12 would be. Hopefully, you were able to figure out that 192 divided by 12 equals 16. If this was hard for you, you'll want to see myself or another teacher to work on your division skills. Another way of writing this, you may not have realized, is with as a fraction, where our fraction bar also is a division bar. So this says the same thing. 192 divided by 12 equals 16. And so what that means is that we put 16 inside each one of these units, we will come up with a total of 192. Now we can go back to our original question. how many of each type of vehicle were registered in August? Let's go back up to our tape diagram. Go ahead and put 16 inside of these and tell me how many pickup trucks and how many passenger cars were then registered. Well, if you rewrote your tape diagram and you put in 16 for each one, and then you multiplied 16 by 5, or you added all 16 together, you'll get 80. If you took the same thing, 16, because this is our constant, our lowercase c, and it stays the same, you multiply 16 by 17, or add all of these 16s together, you'll get 112. So how many of each type of vehicle were registered in August? There were 80 passenger cars, 112 pickup trucks, and if we wanted to check our math, we would easily say 80 plus 112 to get 192. Very good. Moving on to example 2. The superintendent of highways, there's more information going on here. But here we are, back to the superintendent of highways. He's further interested in the number of commercial vehicles that frequently use the county's highways. He obtains information from the Department of Motor Vehicles for the month of September and finds that for every 14 non-commercial vehicles, there were 5 commercial vehicles. If there were 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently use the county's highways during the month of September? Interesting question. Okay, as always, we first start out by saying, what is this problem all about? Then we are going to go ahead and underline what the problem is all about. The superintendent of highways is further interested in the number of commercial vehicles. Now, commercial vehicles are vehicles like trucks and things that are paid by other people to go through. I believe buses also fit into that. Anything that requires people to pay for it to be used. So trucks that deliver food and that kind of stuff. Okay, so those are commercial vehicles that frequently use the county's highways. Okay, again, not the most important information for what we need to find, but it tells us what the problem's about. So he obtains information from the Department of Motor Vehicles, we know as the DMV, for the month of September, and finds that for every 14 non-commercial vehicles, there were 5 commercial vehicles. Remember from our previous example that these are vehicles that are getting registrations. Okay, if there were 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently use the county's highway during the month of September? We should underline our question, and so that really starts here, even though it was a longer sentence. This is the question that we're trying to find. And if we were to use our solve, the question's asking us to find the type of vehicle that was used on the county's highways during the month of September. Okay, now we need to talk about the information that we have. Since this has to do with ratios again, we should find our ratio. So remember our clue words: for every 14 non-commercial vehicles, there are 5 commercial vehicles. So let's go ahead and make that a different color. And now I will take our 5 and make it black again. And let's bold it so it stands out. And our 14. I don't want to lose these numbers. When we have a lot of words, sometimes it's good to separate things a little bit. Okay, so let's take our time and see what questions we need to answer to figure this one out. So since we have our ratio, let's go ahead, as we did in the previous exercise, and come up with a tape diagram. For every 14 non-commercial vehicles, there were 5 commercial vehicles. So our ratio is 14 to 5. So on your own, go ahead and draw a tape diagram. Okay, so now that we have our tape diagram, which represents the 14 non-commercial vehicles and the 5 commercial vehicles, let's continue figuring out the other information that we have. If there were 108 more non-commercial vehicles than commercial vehicles, well, how can we figure that out? If we look at this, we can have this part and this part represent the 108 non-commercial vehicles? Because there were 108 more. So this would have been the same amount. This would be the 108 more. So can we figure out, since this is the only information we have, how many go inside each one of these units if we were to divide up this 108? There's our keyword. If we divide this number 108 and to put it inside each one of these units so we don't have the same number, we would be dividing 108 by 1, 2, 3, 4, 5, 6, 7, 8, 9. 108 divided by 9. Well, can you figure out what 108 divided by 9 is? So we can figure out what goes inside these boxes. Keeping in mind that whatever is in these boxes also go in these units and these units, because it all has to be a constant number, the same number. All right, so I'm hoping that you remembered that when you divide 108 by 9, that you get 12, which meant 12 went inside each one of our units. And as I said, 12 goes inside these units. They have to go inside these units as well. Now we can figure out how many type of each vehicle frequently use the county's highway during the month of September. Well, we could take back to our 14, and it would be 14 times 12, which if you did 14 times 12, and you remember how to do double multiplication, double-digit multiplication, it is 168. Then down here, it is 5 times 12. And that equals 60. So there were 168 non-commercial vehicles and 60 commercial vehicles. Now, of course, the proper thing to do is to answer these in a complete sentence. So we'll do that down here. There were 168. You can go ahead and make sure you've written it on yours. Non-commercial vehicles. And 60 commercial vehicles. That use the county's highways during the month of September. Very good. All right, now we're ready for the exercises. The first one says, the ratio of the number of people who own a smartphone to the number of people who own a flip phone is 4 to 3. If 500 more people own a smartphone than a flip phone, how many more people own each type of phone? Be careful. Don't get confused. Try to do this one on your own, and then come back to the video and see if we did it the same way. Do this the same way we did the previous exercise using the tape diagram. Feel free to go back to look and make sure that you did it. We're doing it the same way. When you're done with exercise 1, then do exercise 2. Sammy and David were selling water bottles to raise money for new football uniforms. Sammy sold 5 water bottles for every 3 water bottles David sold. Together, they sold 160 water bottles. How many did each boy sell? Different from the other ones, this one is together. 3, sorry. Mrs. Johnson and Mrs. Sipple were folding report cards to send home to parents. The ratio of the number of report cards Mrs. Johnson folded to the number of report cards Mrs. Sipple folded is 2 to 3. At the end of the day, Mrs. Johnson and Mrs. Sipple folded a total of 300 report cards. How many did each person fold? Remember, do it on your paper first, then answer the question on Edpuzzle. 4. At a county concert, the ratio of the number of boys to the number of girls is 2 to 7. If there are 250 more girls than boys, how many boys are at the concert? Okay, well, after you drew your tape diagram, you had to continue reading where it says, if 500 more people own a smartphone than a flip phone, how many people own each type of phone? Well, we needed to underline what the problem was asking us to find, starting with how. And then we had to look at the other information we had, 500. So if we talk about the other problem, we started with, when we talked about more, we went from beyond the 3 that they both had to the more. In this case, there was only one more. So if that one more represented 500, then that must mean that 500 was in all of them. So if we had 500 in all of them, we can then figure out how many own each type of phone. Okay, when you put 500 inside each box, because this represents the more, so they all had to be 500, then it's very easy for us to find out how many people own each type of phone. 2,000 smartphones and 1,500 flip phones. Okay, let's go on to number 2. Okay, today, this one we had Sammy and David selling water bottles to get their new football uniforms. Sammy was sold 5 to David's 3. Together they sold 160 water bottles. And how many did they sell? We have to remember with this one that each one of our units is the same amount. That's always most important. So if we have a total of 1, 2, 3, 4, 5, 6, 7, 8, together they sold 160, then we need to write 160 divided by, because we're trying to get that 160 into each unit evenly, and there are 8 units, so it's 160 divided by 8, which would then equal 20 in each unit. Once we know what goes in each unit, we can tell how much each one sold. So Sammy sold 20, 40, 60, 80, 100, and David sold 20, 40, 60. Okay, for number 3, if you put your tape diagram there, and then you realize that you had 5 parts, we had a total of 300 cards. If you divide 300 cards by the 5 parts, then we'll have 60 inside each part, each unit. So therefore, Mrs. Johnson would have folded 120 report cards, and Mrs. Sipple would have folded, or Miss Sipple would have folded 180. I can fix her name just that fast. Done and done. Okay, that was number 3. Number 4 was about the country concert. Okay, for number 4, at a concert, the ratio of the number of boys to the number of girls is 2 to 7. So if there are 250 more girls than boys, how many boys are at the concert? Again, we have to take our more, after they are the same amount, we have to now have a more, and that would be 250. So we can figure out, when we know how much more there are, what goes inside each box. 1, 2, 3, 4, 5. 250 divided by 5 will give us 50. So if 50 is in each box, then we know that there are 350 girls and 100 boys. Of course, they don't ask us about girls. They only asked how many boys were at the concert. So if you would underline that, very good. There are 100 boys at the country concert. Okay, so that's easy enough. Our exit ticket is when Carla looked out at the school parking lot, she noticed that for every 2 minivans, there were 5 other types of vehicles. If there are 161 vehicles in the parking lot, how many of them are not minivans? So you have minivans and other types of vehicles that are not minivans. Okay, good luck with that. Do a tape diagram and we'll see how well you do.